Hello everyone. Finally we do another video. It took me very long time. I'm really sorry. I was very sick, but I'm doing great now. I feel way better, but I couldn't work for a really long time and then I had to catch up with other projects. But now we are back at it and I give my best to go back to weekly videos. Last video we did SAT testing, so we were able to test collision against a convex polygon. And now we are also able to test 2D collision against a circle, which is quite easy. It's just, is the distance lower than the radius, then we have a hit, and if that's not the case, we don't have a hit. And now the question is, for example, how do we do complex collision detections like, for example, Final Fantasy XIV, but in our case in 2D. Which, to be honest, I think Final Fantasy XIV also does collision detection more or less 2D, but that's on another table. And we want two things. First of all, we want to have some data for the server to process, which we get for free because it's just our configuration of the collision. I called it in the code skill collision. And also, it would be great if we take this complex collision and create a texture out of it for Unity to display on the screen so that the player sees where he can go and where he can't go. And that's what we focus today. The code is already in the repository for a very long time, but this is the first time we discuss the code and how everything works. So we have this class called skill collision. Let's check into it. It has a cast type which is needed for our backend. These are basically the different spells that our game has. And we can assign a spell to it, and we can assign how big is the texture on the screen. So if you want to make a, let's say, very simple, a circle that in Unity size, in Unity scale, is 1 in radius, so it's 2 in diameter, then we want this to have a size of 2. Let's do that real fast. And then obviously we need to give this thing a shape. The shapes basically is how does the collision work, and we will play around with that, which makes it way clearer. It's hard to explain as a thing on its own. And if you come here and check out the code, I really suggest you play around with that. So we said this circle has a radius of 1, and we set the position to 0, 0, which is the center of the texture. And we also it's a common vector int, sorry. And then there are two helper functions. One is generate metadata. Let's call this YouTube video JSON. And then it just gets the ELC test. And the other one is generate texture. YouTube video.png. It will be a PNG at the end. And then we can do the texture size. Let's do pixel. So the texture will be 512 multiplied by 512 an X and Y position. but the in-game real world, the in-game world scale will be 2 to 2. So what we have to do is we have to convert between those spaces, the space in our world to the space within the texture and vice versa. That's quite easy to do when you know what you're doing, but it it can be quite hard to understand if you have never seen that before. So let's check out generate texture and let's go through this one by one. And I also want to comment out my mouse wheel sucks. I want to comment out quite a bit here because we go through it one by one, and this would just make things more complicated. So first of all, we initialize a new texture. Quite simple. We have the X size and the Y size. Both are, we always have a square texture. That's fine. And then we have the color format. Pick your poison. I think RGBA 32 is fine. 32 bits for each individual component. Sorry, 8-bit for each individual component, so completely 32 bits, that's totally fine. And we generate MIP maps. This is way better when you scale the texture. And then we have a path where we save the textures, nothing special here. And then if it already exists, then we do not regenerate the texture, which is some kind of caching, because this is done when our game starts. And if we do that all the time, you will see when I activate all the features that we have implemented, it can take some time to generate a texture. But for now, we can disable the caching so that we don't have to delete the PNG all the time. And then we have the word size, which is what we configured. In our case, it's 2 is the size. So what does that mean? Let's go into Unity and I will try to explain. So let's say we cast a spell at the top of this platform. Then maybe let's create an empty. And let's check out where this empty is. Maybe I want to move it around. Had some great values already, I guess. So the platform. When you click on the object, click on scene and press F, it will jump to the object. So we have an object here. It's hard to tell, but it's currently at this point. And what a size of 2 basically means is it goes +1, and if we make another one, it goes +1 in each direction. So it's 68. So it's basically from here to here, and it also goes -1, and the same for the Y coordinate. Since each of these little squares is 1, so when we cast a spell here, because the size in the world is 2, the spell will be this size. That's how the system will work. And if you need a bigger spell, for example, you want to have this whole part here, then you set the size accordingly. And that's how this world size works. And then we first of all fill the texture completely black. So we go through every pixel and do it black. There are better ways to do that, but this is fine. There you could copy whole parts of the texture. For example, you can log the texture to read-writable memory and just write the 30 bits, 2 bits per pixel, and just do a buffer copy, which is way faster to do. But way more complicated to understand, and I want to keep things as simple as possible so people can easily understand the code without having too much knowledge. And then we want to draw the collision shape. In our case, it's just one shape. And then we go for every pixel in the texture. So for every pixel, and we convert the pixel coordinate to the world coordinate. And then we check if it is a hit against our collision object within the world. So how does this work? A pixel is basically X and Y. That's what we have here. And then we have some pre-cached values. For example, text to world is basically world size divided by text size. So world size divided by the texture size is basically a multiplication value which we can multiply or divide against to scale the texture, which is, let's say, 512 to the 2 of our world size or back. So this is just a pre-cached value to multiply or divide it against, depending on where you want to go. If you want to go from pixel to world, then you multiply with it. And if you want to go from world to texture, then you divide against it. That's how this works. And then we have an offset because it's way easier to understand when everything starts at the middle of the texture and not at the top left or bottom left. So this offset just puts everything centered to the texture. And then we go there for every pixel and we calculate if we render the texture at the 0, 0 coordinate, what would be the world coordinate for each pixel, and then we check if it hits the current shape. And if it hits the shape, then we apply the color for if something is hit, and if it doesn't hit the shape, we apply the color for not hit. So the color is black for not hit, and the color is basically a gray, half transparent for if it is hit. And let's really run this code now to show you what will happen. I have to start a game. I don't have the backend started, so it won't start, but I think it will generate the stuff. No, it doesn't. Let's do that real fast and check. Oh, I have the renderer deactivated. That's the reason why. Now it should have generated it. There we have it. A nice gray circle in our texture, which touches the edges. Now we can do funny things with it. For example, what we also can do is we can define a polygon with our S&T testing. Polygon shape. And then this works a little bit different because it gets points. Let's say we have 1 point at the very center, and then we have 1 point, 1 up or down. To be honest, I always forget how it's done. So this basically should be a triangle, and I don't know why it's vector 2. This should also be vector 2. is it not? Oh, it's system numerics vector 2. That's the thing. The reason why we don't use... Oh, it's list. The reason why we don't use the Unity vector 2 is because our backend doesn't know the Unity vector 2. So we have another shape, which is the triangle now, and we can also re-render it. So now we have the triangle. It starts at the very center, then it goes up and left and right by 1. And we can do more complex things. We could go down by a half point and maybe go left by a half point. Go right by a half point. And they need to be floats. If you don't put an F, it's a double for C#. Let's render that again just for the example. So now we have it like that. So you can play around with that, but for me this wasn't good enough. I wanted to have more complex shapes. So what I basically did is I made it possible to exclude things like stands, also remove things from the collision. For example, we can add a circle shape with the radius of a half, but we exclude it, and it's easier seen than explained, to be honest. It basically cuts out something in the collision, and we could even again cut something in, and I think you get the idea. You can make very, very complex collision shapes with that, pretty much everything. You could even make non-convex shapes with that, and for example, you could make a circle and exclude triangles out of it to make a star or something, and we would have pixel perfect collision detection against it. So now we have this small circle again in it. And I think this is good enough for an MMORPG to make collision detection. You could make pretty much everything with it. Let's remove this and go back with the other two that we have here. And let's first of all check how this excluding thing and everything works. So I can remove this, and we have those other two. One is just a circle and one is a boss attack, and they exclude each other, which is because I want my boss to do it like that. I'm just checking how I could change that. So the one is a circle with a, let's say the boss is standing within it, so it's making an AoE around itself, and next time it will make the same AoE with the same size, but only attacking itself, so the player has to move to the boss and can do a couple of hits and then move outside the boss. It will be the level 1 boss, so that's enough mechanic for the player to handle. But this is how this works, and it's quite easy. We have a 24 size, so it's quite a big AoE. And then we do a circle and we exclude the smaller circle out of it, and then we do another collision where just what we excluded is the part of the the collision box. And so we have one where the boss position is safe and one where the boss position is not safe. This is all already in the game and working, but I don't cast it on a boss. I cast it somewhere else on the map, but it was just for playing around. I think it would be a better mechanic to cast it on a boss. We will change that. But still, how does this collision work? So basically what we want to check is when we draw the shape and we want to check out this isHit function. And here it is. So it's actually quite simple. Each shape has a isHit function, which for the circle, quite simple. I don't know why my ID. Oh, it's in common. That's why. Let me really fast boot up the backend because the code is here. Yeah, it makes sense. It's used by both backend and. In the next video, we will talk about how everything works in the backend. Today, we talk about how this works in the front end. So we have this isHit function. Let me remove all other tabs. And this isHit function is implemented by circle and polygon. Polygon is basically our SAT test. We talked about that a lot in the last video, and circle is basically just like I said. If the distance is lower than the radius, then it's a hit. If that's not the case, it's not a hit. We use the distance square to remove the square root calculation out of it. It makes it a little bit faster for the CPU work. It's why not take this low-hanging fruit if we can. And our whole collision system also has a isHit function. It gets the position and in-world position. Everything here is in world position. And it goes through the shape. And if the shape is hit, then the isHit value is set to, if it's excluding, then false, and if it's not excluding, then true. Let's say we have this big circle with the smaller circle, and we check the point in the middle. Then it will check the big circle against the point in the middle, and it's a hit. And then it will say hit is equal to true. And then it takes the next shape, or the next stamp, you can call it, with the smaller circle, and it will see that the position also hits the smaller circle, and when it also hits the smaller circle, excluding is true, so hit is false, and it returns it's not a hit, and that's why we basically carved out the center circle out of the big circle. And if you have a point in the big circle which is not in the smaller center circle, then the first shape will say it's hit because it hits the big circle, and it's not excluding, so hit is true. And then it will go to the next shape, and it's not hit, so no code is executed, it's just totally ignored, and it's a hit. And this is basically working like a stamping system. If it hits whatever you call it last in the list of shapes, then it will get the value that is assigned to it. And this way you can exclude and include like a madman. And since we generate the texture, I figured out why not make the texture more cool, because we now have, sorry for jumping around, we now have a circle, and I want to have some kind of edge detection. I could do it in the shader, which is pain in the ass for the graphics card, because a lot of texture reads, and it will never change because this collision box doesn't change, as we need to generate a new texture. So I wrote a function which is draw highlight edges. Let's put that back in, and let's generate the two textures again, and you will see it will highlight the edges. Like I said, we could do the same thing in a shader. Then it will work with everything. But this is generated one time now, and the shader can just display it with the default shader from Unity, which is way faster. And how this works, it's quite simple. But let's get over it real fast. We go through the texture and we read the pixel from the texture, and only if the alpha value is bigger than 0, basically. Since it's a float, it's best practice to check against an epsilon and not directly against 0. So if it's 0, we ignore the pixel because there can't be a highlight on a pixel that has no collision detection. And if the pixel is not 0, if it's the gray area, then we need to check if we need to highlight this pixel or if we don't need to highlight this pixel. And the thing is, if we want to highlight the pixel, we check the pixel around the current gray pixel, and if one pixel around the current gray pixel is not gray, then we have an edge. So let's say we check this pixel and we go one pixel to the left and we see this one pixel to the left is just plain black, then we have an edge. If we check this pixel here in the middle of the circle and we go to the left and it's still gray, then this is not an edge. And that's how this works. And the thickness is just how far away do we look. So if the thickness is bigger, then we look a little bit further to I just look at the x-axis minus plus and at the y-axis minus plus. So basically I check this cross for this pixel, and the further away we check, the bigger the edge becomes. That's how this works. Really simple. I go through the thickness and check the whole cross. If there is a basically black pixel, and if that's the case, or if we hit the edge of the texture. If we hit the edge of the texture, or if we hit the gray pixel when we check this cross, then this is an edge. If that's not the case, then we have no edge. And we could configure the thickness, make it bigger. I don't have one configured here, so we could make it 3, for example. And if we re-render it, since I checked the whole cross, the bigger the thickness, the slower the algorithm will be, and so you don't want to go completely overboard with that. But now the edge is a little bit bigger. But for me, 2 is fine. That's how we draw the edges directly in the texture, so we don't have to do it in the shader. And there's another thing that we directly can do in the texture, and that is anti-aliasing. So if you ever wondered how a stupid anti-aliasing works, we will discuss that now. So when I enable anti-aliasing, which is 8 times the simplest anti-aliasing you could ever imagine, which takes quite a long time for the textures to calculate because my anti-aliasing algorithm is far from being optimized. And I think Unity might have crashed. No, it's not. Now we have the texture anti-aliased. It loses a lot of crispiness because of my anti-aliasing, but if you render it on the screen, it looks way better anti-aliased than it would without it. We could also do that on the shader, and Unity will also anti-alias, and you also see it rendered here, and I think it looks really good. We also have some code here which will, when you spell an AoE spell, it will scale the texture to the world size that the spell is configured. So if we cast a spell on the screen, this little AoE skill thing here will make sure that the texture has the right size on the screen, so it will calculate how the scale needs to be for it to be the spell that we want it to. What we also can do now, since we have discussed this, we can enable the caching again so that we don't have to wait all the time every time we start Unity. So since we have caching now, the textures are there, it won't regenerate them. And the starting is back fast again. That's what we want to discuss today. And then you can do a texture encode to PNG, then you have the bytes and you can write it to a file, then you have a PNG file, if you wondered how that works. And now we have textures. For generate metadata, it's just we take the object and do JSON serialize it for the backend, and the backend can back deserialize it. Let's remove the YouTube video one, and then we have just the collision shape in JSON format for the backend, and the backend can read that and do its logic, which we will discuss in the next video. So let's not start it. Let's just really look into the rendering. So we have a world size, and this is basically the world size that you give the texture generation. It will go through the renderer and we'll set the world size. And what the renderer does, it checks how big is the sprite on the screen and will match the size of the sprite on the screen to the world size. So let's say, really easy example, when you scale your sprite with just scale values 1, it is 2 by 2 in size, and you want to have it 24 by 24, then you need to set the local scale instead of 1 to 12. And to calculate that, it's just the world size divided by the actual size it currently has. And getting the actual size from a sprite renderer is sprite renderer bounds x10th multiplied by 2, because it's the center point and it extends in both directions. So that's why you multiply it by 2, then you get the full width and height of the sprite on the screen, and then you put your world size divided by that as a scale, and then Unity will scale the sprite to the size that we want to have it. That's the client part, generating the stuff, playing around, generating textures to put them on the screen. In the next video, we will discuss the server stuff. If you run the game, it is already working, and we already have a boss casting those 2 spells. And if you stand in the spell, you will get damage. But this is everything I have today. I don't want to make this video super big. So this is the front end stuff. We will talk about the back end stuff in the next video, and then we will showcase how everything works together. I'm really sorry that I was sick for so long and couldn't make videos. If you were wondering where you can get informed by stuff like that, or you can ask questions, join my Discord, link is in the description. I really try to answer all the questions. You can ask everyone on Discord. They even come with non-game projects to me, and I do my best to help them as much as possible, which I can afford in time and everything. But I help a lot, and it really makes me happy to do that. I love to do that. And if you have any question, no matter how stupid you think the question is, just come to my Discord and ask. I will try to help you, or some of my community members maybe will. Have a good day. Bye.